This is not my house though, but that's what I'm working against. But like all houses, it has a lot of data that could be collected, displayed, and analyzed. And this is my object under surveillance. Everybody sees it's a heat exchange pump, where I have rigged some sensors for runtime things and temperatures and yeah, a lot of stuff. Could be nice with a cable duct or something like that, but not now. It's still a bit prototyping, that it have been for 10 years now. But it's expanding project, so I might need some more connections there. Well, this project, there is a lot of background. Part is the background for my long-running project, and I will end in the microservices architectures and buses and that. So I want to tell the story as well. Maybe I can inspire you to some side projects and some other things. So, it all started around 2003 when I got a new heat exchanger. Right then I was in the Microsoft camp, so it was C++ services running there on a 2008 server, 2003 server it was, and I used an Access database to store all the data. So it was way back. 4 temperature sensors, indoor, outdoor, out from the heat exchanger, into the heat exchanger, things like that. Worked really nice for some time. Have continuous logging with 10 seconds resolution. But after 3 weeks, the database was full. As everybody knew, an Access database can't be larger than 3 meg. Then it's come to a grinding halt, and it's impossible to store any more data in it. Well, there's a solution for that as well. You stop the service, copy the database file, rename it, empty it, compress it, and there, if you have been working with the Access database, do you remember the animated shovel that compacted the database? Really nice. But still, 3 meg was the limit. So, I have to do something to fix this. I managed to run for 3 years that way, but it's ended up with hundreds of 3 meg files of fragmented databases all over the disk, and I never get time enough to put them together again and merge them. So, a bigger database, of course. That's the solution. I added the MySQL database, same setup, just changed the database. No problem, I can log forever and ever and ever. But when you get 3 million data points a year, so after a year it's a bit slow to visualize it, to put all those 3 million data points into one chart, especially with the charting software that was free at the time. And actually, I wasn't really interested in 10 seconds resolution a year ago. So the last hour, a couple of hours, or the last days, it was nice to see it, but not a year ago. So I had to come up with another solution for this. And about that time, I found something that's called round-robin databases. Anybody heard about them? RD tools. They are used a lot traffic on access points and switches and things like that. And it's a really nice way to store data with different resolutions. So, what you do, you set up a fixed size buffer and starting putting in data in that end, and that this one lasts for 1 week, and then drop it out on the other end. So the the file never expand. So it's a fixed size. You know how much it take up on the disk. It's reserved on the disk, so it's really fast. And then when you want more resolution, you add more registers, fixed size. And when it's time to drop down, here it's averaged or consolidated down. And then you get, so then you can keep 10-second resolution for 1 week, and you have day resolution for 10 years. And you know exactly the size of the database all the time. So short time high resolution, long term low resolution. That was just one little problem. It was written in C, so it's a plain command line tool. And now I have changed over to use C#. And there were some not so nice wrappers that you can use the exe file, the C compilation. And it was also written in Java. And at that time, around 2005-ish, I've just started with Java. So have to find some solution. So I made a port from Java to C#. And also managed to introduce some really nasty bugs that show up 5 years later in the consolidation here. So I contacted the original writers of the Java project and said, there's a nasty bug in it. And they said, no way. So yeah, I have introduced it. Well, it was really nice. Yeah, it was written in C in Java. So I have to make a port to C. And well, I know C# at the moment, but Java I was. So the port isn't perfect, I would say. But it's on Java code or Google Code if anyone is interested in it. So now I have almost everything in place. There's also another nice tool with nice thing with the RD tools. There is a presentation package as well. So you can define graphs with data sources, resolution. There is a language for doing calculations, so you can subtract graphs from each other, values from each other. So you can add, you can multiply. So the normal example is that you are logging bits in the router, and then you can multiply it with 8 to get bytes and things like that. So you can do a lot of math before you do the presentation. You can average it, you can make most everything, more or less. So you can do really nice graphs. I have an example of a graph. You can see what I have done something. And it's a really quite big community around it, and there's a lot of things to find on the internet. So I got both the repository, the storage, and I got a package for presentation. So I also made a C# native client to display and set up the charts and things like that. There is in the C version you have command line parameters to set up the chart and things like that in a kind of a language. That's quite nice. But the Java and my C# port, you do it programmatically. And it's nice to do 1 or 2 examples, but when you want to define a new chart with other data sources and things like that, and have to recompile and redeploy everything, it was not so nice. So I actually wrote a parser so I can use the same command line parameters as the C version, and just feed it in, and it gave me an configuration that I then feed into the program. So it's much nicer now. And after 15 years, I realized how Flex worked to make a parser out of another language. So now we have the more modern logger. I have extended it. It's running on a one-wire bus. It's a quite nice concept from Dallas, where you have temperature sensors, digital sensors, and things like that. They hook up to one-wire bus. All those wires you see around the heat exchange pump, that's the one wire. So it's one wire. C# service running, listening to the bus, sending it out to one RD repository and one file repository. And it was humming along for a couple of years. And I used my native client to display the data, the native C# client to look at the data. But then I was thinking about that when I was away from home, I must check the indoor temperature, outdoor temperature, the heater is running, and so on and so on. So I need another presentation, and a web would be really nice to have to put up. But now I was deep into Java, and connecting an ASP.NET application into the RD repository or whatever. No, I didn't like that. So I came up with this one, because those repositories, they are injected by configuration. And it was really easy to just add another one in the configuration that took the data from the logger and send it as a REST message to the application on the eBus server that's listening on the REST port there, or as a REST server. And then I go back and use the original RD for J. So now I'm running on both RD for net and RD for J. So why not? Anyway, it was really nice, really easy to just add the presentation on the Java stack there. And that was great. Now I can check the temperatures, I can check the heater and everything when I'm away from home. But why settle? I looked at this presentation about microservices, and I think that's a nice concept. Have to come up with something that, how can I use it? And recommend it to watch the video there. And I think, well, it's about the bus where we have data flowing, and exactly what I have here. It's data flowing. I can put them on the bus, so I have something on the bus at least. And the bus is the backbone to the microservices. So it was a good start to pick that data. It's hard to find flowing data home if you don't have this set up. So I added Kafka repository. Kafka is the bus, one of the message buses that can be used for microservices. And Fred George's presentation was based on the Kafka bus, so I just go on that one. That was really nice. The problem was, though, that the client for the Kafka bus is written in Scala, and that is client for Java, of course. And I was still running here. And there was a C# client for the previous version of the bus. And the new version was, there was big changes from 0.7 to 0.8. So, well, I wrote an 0.8 client in C#. So that was that was okay. And then I tested, made another repository, and connected it to the logger, and then I got the message on the bus. So now this is a setup of the logger right now. I have the sensors, I have readers, sample processor for data conditioning, the logger itself, and the repositories. And now this is configured and injected into the logger. So it's easy configured. So it's an IOC container, well-structured modules, everything looks really nice. And then I think, where do I put the output in this flow? If I want to control my floor heat, switch that one on and off. This is a logger, it's just for input. This is a repository, just for storage. So where do the output fit in here? And then I realized that this is a monolith anyway, even if it's nice structure and modules and everything. So, the bus, of course. So now we have a new setup. We have really simple modules here. We have the sensors on the one-wire bus, a simple reader, the logger that's read continuously and put the data on the bus. Name mappers, where you map the sensor ID to indoor temperature, outdoor temperature names. Sample processor for averaging, runtime calculation, and things like that. Repository handlers, any number of handlers, any number of repositories and types and things like that. My floor heat logic, fit nice here. It's listening to the temperature readings coming on the bus, and when it's the right temperature and it's Sunday morning and it's dark outside, then I need warm kitchen floor. So it switch on 4 o'clock in the morning. So, but that's the logic part. Then we have the handler here. Next is the remote control system that you can buy at Shell Company, Clas Ohlson and things like that. Fits nice in the picture. And then it's listen on the command coming from here and switch on and off there. Fairly nice, I would say. I don't remember what was the problem with that one. So this is just microservices. And the nice thing is that this is C#. Here we have one Java, one C#. Here we have, could be written in some other language that have native clients, like I'll come back on that one. There, this is the driver here written in C. So I have to do some nice things to connect that one up to the bus. Python, you can have Python scripts there. There it was. And anything. So it's the mix. I will share that a little bit later as well. But the mix of languages on the same bus. So the problem I had before with one that was C#, it was Java, it was this and that. It's fixed with the bus. Yeah. So I made a C# client for that one. And it's on GitHub. So, what can a microservice look like? Well, not more than this. That's why they are called microservices, I hope. don't pay too much attention about it, but what it do, it read data from the one-wire bus, so putting up an callback handler, and each time we read something from the bus, we produce it on a topic name on the bus. So that's about it. The bus, data on the bus. The bus is neutral when it comes to data. It's just the byte arrays. And everything is published or produced and consumed on topic names, on topics. So I'll go a bit further into that later. What I do, the reason I have the serializer here is that I'm sending everything as JSON objects or JSON strings on the bus. So they are readable, they are easy to convert to objects in the Java and the C# end. So pretty nice. So I wrote some command line tools as well to look into the bus. So this is just what you can see. There is topics, different topics that on the bus. If you pick one topic like that one, you can see that it's a number of messages. There is an offset you read messages from, so on. And this is what it looked like on the bus. It's JSON data, right? The bus, you can configure the bus different ways, but one thing, it retain messages. So it's not like a normal event bus where it just exists on the bus and then it disappears. So a client can hook up and get older messages. So if you get out of service for a while, then you can catch up and replay the bus, so to say, or read the messages that you have missed. It gives some problems now and then, and I have to think about how to produce messages, how to consume messages, and things like that. But it doesn't grow forever, so the service is configured to keep a certain amount of messages for each topic, and then it's discarded after that. So, what did I come up with in the end? No, not in the end, but the presentation. It's a very simple web application, just put together to have some display of things. And here you can see the runtime for the heat pump. The red one is when it's producing hot water, and the blue one is when it's running. So this is hot water and this is heat, so to say. And what I've done here, I have two data sources. One that is the runtime for the hot water production, and the other one is the runtime for the pump itself. And then I take the pump itself minus the hot water production, and then I get the red ones here is for the hot water, and this one here is when it's heats as well. And this data can be quite useful now and then, because this is when my daughter takes a shower, hot water consumption. This is when I take a shower. So I can show it to her. This is expensive, you know. It's hot water. And yeah, so it's I'm still working on this one, but this is what could be done, what can be done when I do the presentation from the RD4J repository. So I also made a little proof of concept with the control. I say it's the starting of my floor heat control, so to say. So I have set up hardware. It's another nice aspect of this, because you can, as well as you can mix several languages, you can mix several operating systems, so to say. So here on the on my desktop, I'm running Windows 7, and there's this Telstick dongle. That's the one to communicate with the Nexa relays. I have a Windows server also connected to the bus, and I have the Linux server that's running the actual Kafka services. So I can mix machines as well on the bus. So I'm reading device status from the Telstick dongle and put it on the bus. I get device control back from my services. Then the lamp went on. I made a demonstration for you. I was quite impressed, wasn't you?
You hit the keyboard and the lamp would go.
Yeah, wow, in a web application. So, come to the software setup. It looks like this. Well, C#, C++, Java, and a JBoss application service, and the Kafka service. So, same way as you can have different hardware, you can have different software, different languages hooked up on it. So, then we come a little bit more into the microservices and the concept. And as always, we have to check with Martin what he say about it. And there are several aspects about it. And it's quite new as well. I got the impression there is several fairly large installments running microservices when it's handling publishing and things like that, and advertisement services. But it still feel like a really new technique. But there are several things that you can gain from it. So it's like a service. It's just organized around the business capability. It's not a huge application. You take one service, or we take a business capability and write a service around it. And then come from that also that a team can own the product over its full lifetime, from the development to the deployment to the maintenance. It's just that fairly small part that you have to work with and keep up with. You can deploy them independently. It's not a complete system deployment. So you deploy it, it's connected on the bus. If it doesn't work that good, you take it off the bus again. Instead of a complete deployment. As I said, you can have different languages. You use the skill of the team. If they are better in one language, you do that. You get a better module boundary because you have different interfaces. The bus is the interface. You don't know who you're talking to. You don't know who's talking to you. And from that, it also comes single concern. This service do this thing, nothing else. It's also a difference from other bus solutions. This is the enhanced enterprise service bus. Yeah. And that's a fairly complicated bus with a lot of capabilities. When you run like the Kafka bus, it's a dumb bus, just sending messages on itself. And you can consume it, you can produce and consume. No other services, so to say. And it's easy to put the service in and out. And it depends on the setup, of course, if you can take a service out. I can take the floor heat service out, then I don't get the floor heat on. But the logging is still running. I don't have to redeploy the logger because I changed the logic for the floor heat. I just put another Python script on there, and then it's a new logic. So it's quite nice. And the example on this video was that you log in to book a ticket to a flight to New York. And then the booking system just send a a message on the bus, someone is flying to New York. And then the car rental microservice pick that one up. Then we put up an advertisement about car rental in New York. And then the user log in, and then you get new message on the bus that say, he's logged in, it's this person. He's gold member as us, by us. Then we put another advertisement up. So we just put the advertisement into the bus and you get it in the browser. You know, if you have been on any site and search for anything, then you get to another site, you get all these advertisements up with the same thing. So that's, and if you have it set up like that, okay, you lose money if you can't get those advertisements out on the bus, but still, the book still work. You can still book a ticket, you can still book a rented car and things like that. But this offer services and advertisement services can be taken in and out. And they say like, we put it in there with a business module, and if we don't earn more money, we take it out again. And then we put another business model in and see if we get more hits and things like that. So maybe it doesn't work in banking backend or things like that, where we really have to have every message counted. Because there come some other things with a microservice. The concept, you have no transactions, because you don't have a central database, more or less. Every microservice has its own database. So you're not connected to one database where everybody shares. One of the definitions of a microservice is that it keeps its data to itself. And by that, you don't have transactions. And you have to deal with the inconsistency that could appear. But it's also more like real life. If somebody come into the shop and want to buy something and part of your system doesn't work, you can still sell things, and I have to fix the things afterwards. So you can be a little bit more or less dependent on the system, because, okay, we missed this one, the messages are on the bus, we can rerun them and try to catch up and see what it looks like. Good and bad. Banking system, maybe not. And as I say, there can be loss of data, and you have to deal with it. So it has to be a system that either can fill in the data or can be without the data, so to say. Another concept that we like is it's small enough to fit your head. As I said before, it's small services. You can have a small team, you can keep all the business logic in your head, because it's a single concern service. It's not this huge system with this huge database with all these business rules. They are, on the other hand, they are spread out all over the place, but each of them fits in your head. And they are small enough so you can throw them away. If it doesn't work, it have become old, you don't want to maintain them, you rewrite them. The cost isn't that high, and that's something that North called code half-life. You should consider rewriting sometime, and just not maintain and maintain. So, there is, as I said, there is some problem as well with this catching up, or learn as you go, or keep a history on the bus. Because when I connected this Nexa control to the bus and I start to read from message 0, and I have tested it about 600 times. So it starts to read the control messages from message 0. So the relay was on and off about 600 times, because it was reading all the old message and switch it on and off. So, okay, the output service should just read the last message coming in. So, and then I have the other one that shows the status. of the different devices. Because one setup was to just send the changes to the bus. And then if we get on late, you don't see anything until something happens. Okay, I rewrite the history, I reread the history. So then I have to read through 6,000 messages and found out that the lamp is on. Well, another way is to make the service that send the device status always pull and continuously sending the status on the bus. Then you get a lot of noise on the bus, or you can, something happens, you send the complete state, and so on and so on. So there are some considerations to be done when you set up the producers and the consumers, because it's not always the best way to read from day zero, and sometimes you have to. So
maybe the consumer could ask for data, and someone could pick up that request.
No, you can ask from a specific offset. So the consumer, if a consumer store the last offset read, then you can continue from that offset. Mm-hmm. But it can be an offset that is so old so that it's discarded, and then you still miss some data. So it's not. There's no absolute solution to that.